Hello, this is going to be a quick recap on laws of exponents, also known as laws of indices. But before we look at this element called the laws of exponents or the laws of indices, we will want to find out what exactly is this thing we are talking about. What is this indices? What is this exponent? Much as I am indicating that this is very much like a recap or a revision material, it's very important that we get to the basic definitions and understandings so that in case there was any worry, something that you had not understood quite clearly, it's going to be easy for you to make a connection, to make a follow-up, and it will clear out every single doubt that you had. So what is exponent? Well, the word exponent in mathematics is used to refer to the number of times a number, in this case known as a base, has got to be multiplied by itself. Okay, so we can say, for example, if the exponent of 2 is 3, that therefore means by definition that 3 represents the number of times 2 has got to be multiplied by itself. 3, which in this case we are calling the exponent, and it is also the power of 2, represents the number of times 2 has got to be multiplied by itself. So for the case of 2 raised to the power of 3, or with exponent of 3, we will be having 2 times 2 times 2. Now I'm going to be sharing with you a screen where we are going to be having this calculation, basically where we are going to be having a discussion on how does this identities, or how does this exponent or the definition of exponent leads us to the identities which we are going to be seeing immediately. So I'm going to be sharing with you right away a screen where we are going to be carrying out these calculations. Okay, so I just would like you to check this well, and we will start with, as I indicated, we will start with exponent, the meaning of the word exponent. Now, as I indicated in the first bit or in the introduction, exponent is used to mean the number of times a given number is multiplied by itself. If 2 is the base and 3 is the exponent, then we can therefore say 2 raised to power 3 by definitions mean 2 times 2 times 2 times 2, 3 times. So there we go. Now I hope you are able to see what the screen I have shared with you here. Now here A is known as the base and N is known as the exponent right here. Okay, N is known as the exponent and A is known as the base. Now, does this definition make any sense? Yes, it does. And it comes to give us the first identity here. What does this first identity mean? The first identity, before we even look at the definition, it therefore looks like we have the what? We have the base, which you see here, A. We also have the what? We have the power, which you see here as 1. So now, according to the definition that we have just brought forward, that if 1 is the exponent of A, then that means A has got to appear in the multiplication once. Okay? And what does that mean? Well, that then means if we have some other number, for example, well, if we have some other number, like now A raised to the power of what? Rather, like now A raised to the power of 2. All right, there we go. We say A is raised to the power of 2. Well, let me raise this right away. A raised to the power of 2. In this case, 2 is called the power or the exponent, and A is known as the base. Now, according to the definition that we have just seen, A with exponent 2 means A must be multiplied by itself 2 times. So we will be having A times A times A, like that. And so if A is raised to some other power, say 3, okay, let's say A this time is raised to a power of 3, then what that means by definition is that A will be multiplied by itself 3 times. And so we will be having what? A times A times A 3 times. Well, we can use this to give the general expression. Now, what if A is now raised to some other power? Let's say n, okay? If A is raised to the power of n, what does that mean? Okay, A raised to the power of n. This then means A will be multiplied by itself n times. That is A for the first time, A for the second time, A for the third time, A for the fourth time. You know, we keep multiplying until we get A n times. Okay? Until we get A n times. That is what we mean by what? By the power or the exponent of a number. Now, notice that in this case, we have been using what? We have been using A. This is true even if we will not be using A. For example, what if we had decided to use some other number? All right. Let's say instead of using A, we were using a number like 2. So that means 2 raised to the power of 1, okay? 2 raised to the power of 1 means we have to multiply 2 times itself once. In other words, 2 is appearing once. Now, if we are having like 2 with a power of 3, maybe for example, or maybe 2 first, then this will give us what? This will give us 2 times itself, that is 2 times 2, making 2 appearing 2 times. We could think of any number. Now let's look for another number this time. Let's say 5. 5 raised to the power of what? 5 raised to the power of 3. Or 5 with exponent 3. So we'll be having 5 exponent 3. This will give us 5 for the first time times 5 for the second time times 5 for the third time. This is what we get, and this is going to make a lot of meaning in the next examples, which we will be what? Which we will be looking at. And we are calling this the first identity. Okay, this is going to be the first identity we are looking at. Well, what is the second identity we want to look at? The second identity we want to look at comes from the fact that if a number, say A, is raised to a power of 0, that is, if a number or a letter A has got exponent 0, what does this give us? Well, this then means the letter A must be multiplied by itself 0 times. You know that? Well, turns out that any number or any letter raised to the power of 0 is what? Is 1. Now, notice that this one is true, that there are times when we will want to write it in the reverse way. There are so many times we will be seeing in the next series of examples, or as we will be coming to the actual laws of indices, we will be looking at the reverse way of writing these laws. For example, there are times we will write 1 as what? As A with the power of 0. and it will make a lot of sense. Now, the third identity that we would like to look at, well, how do we call this third identity? Well, the third identity we want to look at is that if a number, let's say, or a letter, has not been written with an exponent or a power, what does that mean? For example, let's say we have A. Can we express A as a letter with an exponent? That's the question. Well, it turns out that this is very possible. We can go ahead to express this with an what? With an exponent. And so A can be written as A with an exponent of what? With an exponent of 1. Okay, this is true for any number. For example, you could have another number, let's say, or a letter, let's say B. So if you have a letter like B, this can also be written as B with what? With the exponent of 1. Now, this is true even if we are dealing with what? With numbers. Let's say this time we are having the number 4. The number 4 can then be written as what? The number 4 can then be written as 4 with the exponent of 1. Okay, the exponent of 1. Now, notice that the reverse of this is also true. We can get the reverse way of writing it. And what is the reverse way of writing it? Well, the reverse way of writing it, for example, is like if we have 5 with exponent of 1, we can then go ahead to write this as 5. Okay? Now, if we have some other number, say 7, with the exponent of 1, we can also write that as 7. So this is the third identity, very much like a way of reminding ourselves of how to get this done. Now, as I indicated earlier, this is going to make a lot of sense in the what? When we begin to deal directly with the laws of exponents, which is going to be coming shortly. But before we get to there, it's very important that we capture or we understand these identities very well. It's very, very important. These identities, we need to understand them very well. Well, what's the next identity that we are supposed to be looking at? Well, the next identity that we are going to be looking at is an identity which comes with, that is number 4, which comes with a power which is negative. For example, we had already seen that if we have a letter, say A, with exponent n, this then means by definition that A will be multiplied by itself n times, like A for the first time, then A for the second time, then A for the third time. You know, we can keep multiplying it again and again and again up to when? Up to n times. Okay, up to n times, like that. Well, now here is the question. What if we have this expression this time written as A with exponent negative n? What does this mean? And how do we deal with this? Well, it turns out that one way of making this or of turning this around is to get the reciprocal of the whole set. So now what do we have? Well, we do have A power negative n. And so how do we write it without a negative exponent? Because a lot of time it will be very important for us to find a way of simplifying, you know, to find a way of writing exponents with positive values instead of having exponents with the negative values. And so one way of dealing with that is to get the reciprocal of the whole quantity. And that gives us 1 divided by what we had been having. Only that in this case, A will be having a positive what? a positive power or a positive exponent, which you can just write it without anything plus or minus. You can just keep it as a power n, from a power negative n to a power what? To a power n. And this is how you deal with quantities that what? That have got negative powers. Now notice that there are times when it's going to be very important for us to look at the reverse. And so what is the reverse of this thing we are dealing with? Well, the reverse of this quantity we are dealing with, that is, if we have now a quantity like 1 divided by a raised to the power what? Raised to the power of n. What will this give us then? This will then give us a with the power of what? Negative n. The reverse is true. So for all these identities that I have brought up here, all these things work wonders both ways. The left-hand sides of all these identities can be written as the right-hand side of the corresponding identities. And also, we can start from writing the right-hand side and we get what we had written with on the left-hand side. Well, what will this then lead us? This is supposed to lead us into what we now call the laws of what? Of indices or laws of exponents. Laws of exponent. Sometimes known as laws of indices. What are these laws of indices? Are they important that we deal with them? Well, it's very important that we deal with these laws of indices. It's very important. The first law of indices, or the first law of exponent, states that, remember, we had already seen each of this time I mentioned the word exponent, what should come into your mind is that exponent represents the number of times a quantity called the base must be multiplied by itself. There are rules that we follow, which in this case is being described as the laws of exponents. And how do we deal with this? Well, we just have to follow the rules. For as long as we get the rules right, and for as long as we follow them correctly, we won't go wrong. What does that mean? Well, this then means we start with the first law. Now, the first law, or the first rule of index, rather exponent, states that if you have a number multiplying itself, then what you do to evaluate it is you add the exponent. Let's say we have a number a. The number a is multiplying itself. Now notice, we could write it as a times a. Or, to make it a little bit easier, let's write it with exponent. Let the first exponent be n. And let the second exponent be m. Now, what we get from this is that since the base or the bases are the same, they are all a and also a, we will then have to deal with what? We will have to deal with the exponent. We don't deal with the base anymore. We just deal with the exponent. And what will this give us? Well, this one will give us the exponent of n plus m. Now notice the reverse is true, okay? Before we even move to look at how we can go ahead, to deal with how to simplify one or two of these, let's just put the reverse right away. The reverse then means, should it occur that you have a number a, known as the base, this time with exponents being added, for example, 2 added to 3. That therefore means this one came from a raised to power 2 times a raised to power what? raised to the power of 3. That is how we reverse it. It's very important that you understand both sides of the what? Of the rule. Now, since we are using n and m, let me use instead n and m. So the whole thing here will then, all right, just right away here. Sorry. All right. So this is what I wanted to say, that since we are using n and m, let's substitute 2 with n and what? And 3 with m. So that we get a power 2. Instead, we now get a power n. A power n, let me just put it right away, a power n. Then a power what? Instead of 3, we now have m. And so when we substitute it with the numbers, when we put numbers instead, like n represented by 2 and m represented by 3, then this will give us a times 2, that is power 2, times a raised to the power of 3, or exponent of 3. Okay? So it's very important that we get that. These laws of exponent, they work both sides. There are times when it's very important for us to know what is on the right hand side and how to bring it to what is on the left hand side. That is the reason I'm bringing this up front. Well, how can we apply this? Well, we can apply this in a number of questions. For example, we can then say, this is just an example. If we have been given that we multiply 2 times, again 2 with the power of, say, 3, what will this give us? Well, this will give us 2. Now, notice that this 2, we had already seen in one of the identities up. Okay? In one of the identities up, we had seen that a number which is written without a power, that same number can be written with a power of 1. And so if we are required to multiply 2 times 2 raised to the power of 3, we will do ourselves a favor by starting with indicating the power of 2 as 1. This is the first 2. And then later, we multiply this. We then multiply this with 2 and this power of 3. Okay? At this point, we can now go ahead to apply. Now, notice that applying this first law of indices required us to remember the other identity. And so the identity part came in the second step. That is one part where it's very important for you not to forget the identities. And so what do we do at this point in time? Well, we just go ahead and simplify what we have been given. You know, the rule is so clear that if you are multiplying the same base, then you evaluate it by adding the what? The power or the exponent. And so what we do here is we then be having 2 with the exponent of what? 1 added to 3. And what will this give us? Well, this will give us 2 with exponent of what? With exponent of 4. This is how we would what? We would deal with this question. We could look at another example. For example, if we have been given this time we have been given, let's say 3 power 5, all right? 3 with exponent of 5. And we are multiplying this with 3 exponent of 2. That is times 3 exponent 2. What is this going to be? Well, this is going to make sense if we just get straight to the rule which we have been given. And now what is the rule? The bases are the same. And so what do we do here? Well, we just simplify. We say this is equals to 3. Then we add the what? We add the exponents. And the exponent being 5, which we now add to what? To 2. What is this supposed to give us? Well, this is supposed to give us a 3 with an exponent of what? Of 7, which comes after adding 5 to 2. Now, this looks a little bit easy, but let's first do one more example. So we will say, in this example, we have x being raised to the power of 3. Okay, this time we have x being raised to the power of 3. And this is multiplied, okay? This is multiplied by what? It's multiplied by x raised to the power of 8. So this second x is raised to the power of 8. In other words, it's having exponent of 8. So how do we deal with this? Well, this will give us x with exponent of 3 added to 8, which we can go ahead to simplify as x with exponent of 11. And maybe one more example. Okay. So in this next example, we want to deal with a letter also. This time is n. Okay. So in the next example, we have n raised to the power of 2 times, okay, times n raised to the power of 10. So how do we simplify this? Well, to simplify this, we say since the bases are the same, we would have n with the power of or exponent of 2, this time added to 10. Now notice that when we add 2 to 10, we get 12. And so the final result will be n with exponent of 12. Now this one has been technically or almost obvious. Okay, this one has been relatively easy to see. Only on the first law of what? The first law of exponent. Now, there are times when you will not be given very obvious questions, okay? You may have to deal with questions that are not so open. For example, if you are given the number 2 with exponent of, well, 3. And now this one is being multiplied with 8 and exponent of, with exponent of what? With exponent of 2. Well, you could say, but wait, the bases are not the same. And so we cannot apply this law. We cannot apply this law to work on it. Well, it turns out that the bases are different at first, but they can be made the same. Okay, they can be made the same. How can we make them the same? Well, notice that the first base is already reduced to the simplest form, and so there isn't anything we are going to do. What we are going to fix there. And also, the other thing we want to do is this. When it is very important for you to make the bases the same, you look for the smallest base and you try to do what? You try to make the other base as small as the smallest base. And what is that supposed to mean? Well, this is supposed to mean 2 with exponent of 3 will not be disturbed for now. Instead, when we are multiplying, instead of writing 8, we then write something else. And what is this going to be this time? Well, 8 this time is going to be written as 2 times 2 times 2. Well, how did we get to that? Notice that 8 is the same as 4 times 2. And 4 is the same as 2 times 2. And so we can write the whole thing as 2 times 2 times 2. And what should this give us? Well, this is now going to give us 2 times 2 times 2 with exponent of what? With exponent of 2. You see that? And so what do we get for that? Well, we will get 2 with the exponent of 3 for the first one, for this one, which is the first here. Then we will multiply this. Notice that what is inside the bracket? What is inside the bracket can be written as 2 with exponent 1, okay? We had already seen that a number without exponent will be having exponent of 1. So you could write this as 2 with exponent of 1. Then this time we multiply it with 2 again with exponent of what? With exponent of 1 for the second 2. Then now for the third 2, we also do what? We also multiply with the 2, then exponent of 1. And then we maintain the exponent we have outside, which is what? 3. Rather 2. And so we can still go ahead to simplify this. Now notice that we are so close to the final bit. And so we will then be having 2 with exponent of 3 times, that is times 2, which is inside the bracket. The 2 inside the bracket will now have added power. That is when we add this 1 to this other 1 and to this other 1, we will be having what? We will be having 2 with exponent of 3. But notice we have some other 2 outside the bracket. That 2 outside the bracket is now used to multiply the 2 inside the bracket. Rather, is now used to multiply the power of 2, which is inside the bracket. So we multiply this. So in a very precise way, the final answer will be what? The final answer will be 2, okay? Because when we multiply 3 for the index or the exponent of 2 inside the bracket with 2, which we already had outside the bracket, we will get 6. Okay, we will have 6 for that. And so we will then be having 2 with exponent of what? We'll be having 2 with exponent of 3, 2 with exponent of 3 times 2 with exponent of what? With exponent of 6. And so we can still simplify this. Now at this stage, we can go ahead to apply the what? To apply the other law. Now notice that a lot of times you will have to go through these steps. And you have to make sure you don't skip any single step when you are required to solve this. Make sure you don't skip a step when you are required to solve this type of problems. Okay? Now, in this case, what we are going to be having is 2 with exponent of 3. This time we will be adding the exponents. That is 3 plus 6. So that the final value will be 2 with exponent of what? With exponent of 9. So this is a step which you don't want to miss. And it's a very important step. So just a quick recap. The whole thing here is we were given a question which is 2 power 3 times 8 power 2. Now, at first sight, you would be tempted to think, well, 2 is not the same as 8, and so we cannot apply this rule. But we saw that this same 8 can be simplified into what? Can be simplified into 2 times 2 times 2. In other words, 8 can still be made to look like 2. And the whole process of making 8 look times 2 looks like 2 is what we have been doing here. And that is what took the most part of our what? Of our steps. We needed to make what? We needed to make 8 expressed as the prime factor, or very much as a product of the factors. You see? So this is what we get. So 8 being written as 2 times 2 times 2, with each 2 being represented with a power. Okay? In other words, we could have skipped these steps. We could have skipped the second step, but as I indicated earlier, it's not always a good idea to skip steps. Always make an effort to include all the steps, because that way you rarely make mistakes. And so we saw that 8 can be written as 2 times 2 times 2. Now notice 8 is having a power of 2, and so we had to place the 2 outside the bracket, so that the 8 now broken into 2 times 2 times 2 stays inside the bracket. And then in the next step, we still write the first term the way it is, which is 2 power 3, then times. Now this 2, 2, 2 can be written as 2 with exponent of 1 and 2 exponent 1, then 2 exponent 1. Because we had seen that a number without exponent is the same as that same number with exponent of 1. And so because of this, well, we could just write it as 2 power 1 times 2 power 2, rather 1 times 2 power 1. Now this way gives us easy way of dealing with it. So we have to deal with what is inside the bracket first before we then simplify the whole thing. So this is the first stage when we will be using the law which we have been given, that when you're multiplying numbers of the same base, you do what? You add the what? The exponent. And so the first law has got application here. Then when we are done with that bit, we get what? We get 2 power 3 right here times 2 power 3. Now notice this 2 which is outside the bracket is now used to multiply the 2 which is what? That the 3 inside the bracket is used to multiply the 2 outside the bracket. And so when you multiply 3 by 2, what you get is a what? A 6. And this 6 which we have got here is now the exponent of the 2. And so we can then apply the other law of exponent, which states that if the numbers are the same, if bases are the same, we can go ahead to add the what? The exponent. And this gives us what? 2 power 3 plus 6, giving us 2 power 9. Okay. Now this is one example in which we were supposed to do what? We were supposed to deal with a base which is not the same. Now, each time you find a question where the base is not the same, the only way out is to make the base the same. That is the only way you can deal with that problem. Simply make the base the same. There are times when you have to deal with the letters mixed with the numbers. And also, you have to apply this what? This first law. Now, in the event that you are supposed to do that, you have to do the simplification before you do what? Before you apply that rule or the law of exponent. Well, what am I talking about? Well, supposing that we have as one additional example. Let's say you have been given 2a with exponent of 3. And this time, we have to multiply this, which we have been given, with 6. Okay, with 6 times a. What will this give us? Well, To deal with this, we will want to do grouping. The numbers will be multiplied separately and the letters will be multiplied separately. What are the numbers? The numbers here are 2 and 6. Okay, 2 and 6. And so how do we deal with the 2 and 6? Well, we will want to put them inside what? Inside their own bracket. And so we will be having the numbers S2 multiplying what? Multiplying 6. Then now, how do we deal with the A? Well, we could also have them in their own bracket. So let's have a separate bracket so that it's easy to deal with it. And so this time we are having A with exponent what? A with exponent 3. And it is used to multiply A with what? With another exponent. Well, what's the exponent this time? The exponent is 1. It's always very important to indicate it there, exponent of 1. Now, notice that after grouping this, it becomes a lot easier. You know, after grouping it, it's a lot easier to go ahead and apply the what? And apply the rule. Now, for the first one, we will just use the same rule of what? Algebra. You know, just obviously multiplying it and getting the answer. And so 2 times 6 will be what? Will be 12. So we write it there. Now, this 12 is used to multiply what? This 12 is used to multiply A, which is having exponent 3, times A, which is having exponent 2. Now, you know what? We could have this in their own bracket, as I indicated earlier. So, this is going to be A with exponent 3. Now, this time we will go ahead to apply the rule, which requires us to add the what? The exponents of A. And so, in the next step, we will then be having 12. We will be having 12 in the next step, times A times with the power of or exponent of 4, which is very much like 12A. 12 times A is 12A. This time with what? With exponent of 4. That is after adding what? After adding a 3 and a 1 to get a 4. So there are so many ways in which we may be tempted, you know, to deal with this type of crisis. Still under this first law of indices. Now, just one more question, or rather one more example, which still uses this law of what? The laws of exponent or indices, which we call the first law of exponent. Supposing that we have been given, this time we have been given letters and numbers combined. Okay, we have been given 3x, 3x, x this time has got exponent of what? Exponent of 2. So we have got 3x with exponent of 2. This have been multiplied with, rather, 3x exponent 2 with a y. Y has got exponent of 3. Y has got exponent of 3, so we write it right there. Now this one is used to multiply some other quantity. This time 5x, this time 5x, y with exponent of 2. You see, this is still under the same thing, the same law, only that it's a little bit expanded, it's a little bit compounded. You know, there are now a number of items here, a lot of things. How do we deal with it? Well, we obviously have to group things the way we had seen in the what? In the previous step. We have to group things. together. I mean, items that are similar are grouped together. Items that are not similar are kind of separated so that it's easy for us to deal with it. So what is this supposed to mean? Well, in this case, simplifying this will take a step, right? There are steps we will have to go through. The grouping here will take the following forms. We will have to group the numbers separately, okay? Then later we group the what? We also group the letters separately, this time starting with X. Then when we are done with X, we will also have to group the what? The Y. So let's see how it will come up. We have 3, that is a 3. Then we also have what? We also have a 5. Now these have been multiplying themselves, so we have it there 3 times 5. Now the next thing we want to deal with is X. So we have got X, which is here. This X has got exponent of 2 times. There is also another X, which has got exponent of what? The exponent of this X is 1. Now we go ahead to move to what? To move to Y. So the first Y value has got exponent of what? Exponent of 3. Now this first Y value is used to multiply another Y value, which has got exponent of what? It has got exponent of 2. Yes. Now we have done the grouping. What do we do next? Well, the next thing for us to do is going to be to multiply. Just that, we will just have to multiply. And so this will give us 3 times 5 is 15. Then now we multiply this with this axis. So we'll be having, well, we can put the multiplication sign there, or we can even ignore it. We can leave it. We just put a bracket. That's just enough. But just for the sake of keeping it there, let's have the multiplication. So this time we have X. Now notice that because the base is the same, there is X here and X there. We will then have to apply the what? The rules right away. And the rules allows us to add the what? The exponent. What are the exponents? 2 for the first value of X and 1 for the second value of X. We then, after this, move to what? Move to the what? To the bracket of Y. And what do you get from the brackets of Y? Well, from the brackets of Y, we have got Y. The first Y value has got exponent of what? Has got exponent of 3. Now we add this to the other what? To the other exponent, which is what? The next exponent for Y is 2. What do we get from this? Well, what we get from this is going to be a 15, then X with exponent of 3, then Y with exponent of what? With exponent of 5. And this becomes what? Our answer. So notice that this recap was meant to make an extensive explanation of what we call the identities that are very important for us in exponents and also the laws of exponent. But we have looked at only the first law of exponent. That means the second law of exponent should be coming in the next series of videos, which will be coming shortly. And so, in case something is not clear, if there is something which is not very clear, just feel free. You can rewind the video, you can play it back, and you get what it's supposed to come out from this. So this is how we deal with exponent.